Hey, we are doing another lesson here, real fun. Bit of a shorter one and a bit of a different format, but we'll see how we get kind of through it. Section 10.3, you notice that not a PowerPoint, we're using just a Word doc here. The idea was that in class you were supposed to sort of just fill this in on your own. It was going to be like a work period type situation, but every day is a work period, so I thought that we would just go through with it. I have the blanks filled in. I'll post this as well so you can read through it on your own. I'm just going to go through it sort of quickly, and I can cover any gaps if you just send me an email or ask me a question. The charges at work section, this is 10.3 in the textbook I have up here as well. The note obviously follows along very closely with it, so if you want to follow along too, then just use your textbook. It is looking at some of the practical applications of the stuff that we were talking about. We were mentioning about static charges and how they and just how they work. And now we're going to look at some of the applications of that. The biggest one's probably going to be lightning in terms of how lightning forms. So we have the text here saying, Ben Franklin was one of the people that showed how electric discharge would occur, like in nature, obviously with lightning. So Ben Franklin and electricity is tied to him in that sense, right? Like he had, like I think it's like the key hanging off of the old kite is the sort of vision we have of him. So it's a transfer of charge that we're talking about. Um, Moderate thunderstorms equal to that of a small nuclear generating plant. So lots of energy that are produced. Storm clouds are raindrops, ice particles, and then updrafts. And then we have how they move around in these clouds and collisions occur. So basically, what's happening is that in the clouds, water and other particles are moving around and generating friction, and this creates charge because we create the ions. Hopefully you remember what an ion is from the chemistry section, just a charged atom. So ions get formed, or we have maybe groups of ions, and we have some that have gained electrons and some that have lost. And then we can see the visualizing of lightning. So the question, what type of charge will the negative charge in the bottom clouds induce on the surface? And it says here positive. Let's take a look at the textbook because it has some pretty good images. So here's a nifty little National Geographic intro. This is like an insert into the textbook. So you see that as this stuff moves around, we create ions, we get a charge. But remember that clouds are fluid, right? So these particles are moving around. And then what we end up having is that the bottom gets more negative charge. The positive charges tend to kind of go up to the top. The bottom of the cloud becomes negatively charged, right? So what's that going to do? This negative charge is going to induce, right? Remember, this is now, so charging by friction going on inside the cloud, and then now we see that charging by induction happening here, right? The negative charge on the bottom of the cloud pushes the negative charges on the surface of the earth, like in the tree, your house, whatever. It pushes those negative charges down, leaving only the positive charges. So now we have an attraction, right? So that's charging by induction, happens later on. Then when we have enough charge that has been built up, we see that this attraction is too much to kind of stop. And so we see that the electrons in the bottom of the cloud move towards the ground, right? So these electrons, because remember that negative charges are the only ones that move, they will actually go now to the ground, right? In an attempt to get grounded to get rid of this charge, right? When they get close to the ground, they attract positive ions that surge upward, completing the connection between the cloud and the ground. This is the spark you see as a lightning flash. And then so basically they sort of connect each other, right? As these negative charges sort of start moving down, the positive ions, remember, sorry, and then some of these positive ions can move up to sort of complete the connection. And once the connection is completed, we see the discharge as the lightning bolt, right? And this can occur when it strikes the ground. Similar things can happen between clouds as well, and which is more common than lightning actually striking the ground. Sometimes you don't even, a lot of the lightning is sort of not evident in that. So I want to just point that out. those four sort of steps about how lightning forms. So static electricity is the reason for lightning, right? And this just talks about it with some of these charge stream called a step leader, right? Of the positive charge that moves, return stroke, all of these are just sort of fancy names for this happening. This is interesting. Lightning takes the path of least resistance between a cloud and the ground, usually hitting the highest object. It will damage any unprotected tall building, tree, or person it hits because of its very large electric current. Lightning causes between or within clouds, like we mentioned. So the reason that lightning strikes tall objects is because that's the shortest pathway, right? That's the shortest way for it to complete the connection there, right? So that's what lightning is looking for, a way to get to ground, and it can do that however is possible. Now, what we have here is a picture of a lightning rod. Lightning rods can be installed near on tall buildings like skyscrapers, or can be attached really anywhere. And basically what a lightning rod does is it will attract the charge of lightning, but it is connected to the ground and insulated from like the building, right? So what that means is that when lightning strikes the lightning rod, electricity passes through the lightning rod and then through like a wire that will maybe be connected to the ground or be connected somewhere else. What this means is that wherever the lightning rod is, the lightning will strike that point instead of the tree, instead of like this other point on the building, right? So basically, attaching a lightning rod, if it's done correctly, will prevent the building from getting damaged. You see I think there will be a picture in the textbook. You see lightning rods on tall buildings. I can't remember if there's an image. I guess there's not. But you see lightning rods on tall buildings all the time because skyscrapers in cities, they're so high to the clouds that they get struck by lightning a lot. So you need to install a lightning rod so that you don't have any damage done to the building. So reduced likelihood of lightning strike, and strike occurs to conduct charge safely to the ground. So that's what's called a lightning rod. Basically, it neutralizes the charge that happens, right? What safety precautions be taken when you can count 30 seconds or less between flash, lightning, and thunder? It says take shelter. Remember that you can do this little nifty thing is that when you see a flash of lightning, if you start counting to yourself the time that it takes before you hear thunder, the shorter the time means that the storm is closest to you, because obviously light travels faster than sound. But if you see a flash of lightning and then almost immediately hear thunder, it means that the storm is very, very close to you. Whereas if you see the lightning and then you hear thunder like a little bit after the fact, then it means that the actual storm is further away, because it takes longer for that sound to reach you, right? But light travels so fast you can see it from very far away. Some things you don't have to fill these blanks in, because this is just drawing these diagrams here. These four diagrams is just supposed to go in these four blanks. Okay, let's go on to another application. Getting rid of pollution. Electrostatic precipitator is a type of cleaner that can remove particles, liquid droplets from a flow of gas. It can be effective for reducing pollution from smokestacks. How does a precipitator work? Dust particles in a polluted gas get positively charged when they come in contact with strongly positively charged wire. These induce negative charge on the collection plates. When they collide, they are neutralized and collected in hoppers. Clean air gas goes to the smokestacks. I think there was a picture here. One more. Yeah, right. So these precipitators, you just essentially just charge ions in the gas, and then if you have a collector plate that's the opposite charge, then all of those charged particles will get stuck to the plate, right? And then you can do it in such a way that you only charge the pollution particles, and then all the other particles can go through unimpeded. So that's an electric precipitator. That's another application. So we see lightning, we have this precipitator. Electrostatic spray painting is another one, where very similarly, you chart whatever you want to be painted, you attach with an electrical wire and give it a charge, and then the paint that you use in the canister also has a charge of the opposite polarity. So what that means is when you spray the paint, all those particles get attracted to the surface of the material. So in this case, this is a guy painting the side panel of a car. Not side panel, I guess it's like the front, wheel well, whatever you call this part of the car. But he's painting this part of the car, and all of the paint has a charge, and then the actual surface of the car is temporarily charged because it's connected, and so all the paint sticks to it, right? So this is just nice and efficient, and and then make sure that you don't lose any paint, right? So it'll minimize the amount of overspray. So you can do that with spray painting, and in this case for like vehicles, right? Another application is called a Van de Graaff generator. These are very common. These are the things that if you, where you one person touches it and then the other person holds their hand, you know, and you make a big chain, and then it conducts the electricity all the way through, right? It accumulates charges, and it can also transfer these charges. So we have the sphere on the top is on an insulated column. Then there's a belt that you turn the power on, this belt will start to move, and this creates friction, and then the friction will create a charge buildup, right? A static charge buildup. And so if nothing touches the outside of the surface, it'll just continually building up charge so that the charge will accumulate, right? And then you can discharge it in a lot of fun ways, maybe with a person touching it, or touching it with like a rod or something. If you Google Van de Graaff generator, you can find lots of interesting videos on that, right? And they've been used for a long time. They can test electronic circuits and space technology. So that's another one. Photocopiers also rely on static electricity in order to make copies. So the photocopiers that are in schools or whatever use this same stuff as well. Okay, different light conditions, effectability of selenium. That's just an element. You can find it on the periodic table. To conduct electricity, selenium is only a fair conductor, right? It's a semiconductor. But it's only a fair conductor in the dark, but it becomes very good when it's exposed to light, right? And so he put this guy, Chester Carlson, put it into a photocopier machine, and then a photocopier laser printer scan electrostatic images made on an aluminum drum coated with selenium. So what we see here is basically we generate some more friction. We have what's it called? The toner image. And then that toner will get attracted to the paper, and then basically the ink gets attracted to the paper and gets stuck on it in a particular pattern, and then that paper shoots out with whatever the original had on it, right? And so this toner drum gets like the image of your original on it, and then as soon as it's done, the charge goes away, and then the image is lost, and then that's why you can repeat it a bunch of times, right? And then radiation dosimeters. Dosimeter is a small device that detects how much radiation there is. People who work with radioactive materials, like in nuclear power plants, right? They need to wear these things when they go into work to see how much radiation they're being exposed to and make sure that it's within the safe levels, right? Because we all are actually getting exposed to a certain amount of radiation in everywhere we go, everything we do, and we refer to that as what's called background radiation. It's harmless. Our bodies are fine, right? Our bodies know how to deal with it. But if you go into a place that has more than background radiation, obviously your body may not be fine. So you have these little badges that you can put on that will detect it. And X-rays can be hazardous in single high exposure. So basically what happens is the radioactive materials, I think if there's anything radioactive in the air, it'll generate a little current in this badge. It'll create like a static buildup or whatever, and then the more like static that's built up on the dosimeter, then it'll tell you how much radiation there is, right? Like there's a way to explain it in there. Sorry, that was not a very good explanation, but as long as you know what they are, I think that's the important thing there. Okay, perfect. So go through this section with all these little examples that we had from the thing. You can also try this here. This might be kind of fun, right? If you take salt, pepper, a plastic spoon, paper, and a wool cloth of some kind, basically you put salt and pepper onto like a sheet of paper or something. Maybe, well, if it's colored paper, you can see the salt a bit easier. The pepper will stand out no matter what. Then basically rub the spoon with the wool cloth. So basically take something plastic, rub it with wool, right? Obviously, depending on the type of plastic that you have, it'll react a bit differently. But you can try different plastic objects with different articles of clothing, right? Depending on what it is. If you look at the tag for the clothing, it should say like 100% wool cotton. Then it'll probably work better. And then basically bring the plastic thing down towards the salt and pepper mixture, and then see what happens. So think about what you expect to happen, and then give it a try. Might be kind of fun. And that's it for 10.3. I thought there was something else I wanted to show you, but I suppose not. Anyways, that's another great lesson. Talk to you soon.